Our tongue is the sense organ that can distinguish a wide variety of taste in substances that we eat. These substances can be grouped on the basis of whether they are sweet, salty, sour, or bitter to taste. The following table 1 contains a number of substances that you taste in food or as supplements.
Substances like tamarind, unripe mango, lemon, and vinegar are sour to taste. Baking soda is bitter, whereas seawater is salty. On the basis of the above, chemical substances can be broadly classified into the following 3 types: acids, bases, and salts.
Chemical substances. Acids, sour in taste and corrosive in nature. Bases, bitter in taste and soapy to touch. Bases that dissolve in water are called alkalis. Example, calcium hydroxide, sodium hydroxide. Salts. Salts are neutral. These are neither acidic nor basic. They are formed when an acid reacts with a base. Example, sodium chloride, calcium carbonate. Organic acids. These are naturally occurring acids present in animals and plants. Example, citric acid in oranges, malic acid in apple. They are weak acid. Inorganic mineral acids. These are manufactured from minerals synthetically. Example, sulfuric acid, nitric acid, hydrochloric acid. They are strong acids. Acids.
Ions. These are charged atoms or group of atoms. There are cations with positive charge and anions with negative charge. Example, H positive is hydrogen ion and OH negative is hydroxyl ion.
A number of fruits and some of the common food you eat are sour in taste. All citrus fruits contain citric acid. Fermented milk and curd produces lactic acid. The sour taste of vinegar is due to acetic acid, while amla is a source of ascorbic acid. Some of the naturally occurring acids are given above in Table 2. Thus, acids are chemical compounds which have a sour taste. Materials containing an acid are called acidic substances. All acids contain hydrogen atom, which in aqueous solution are present in electrically charged form called ions. The production of hydrogen ion, H positive, when dissolved in water makes the substance behave like an acid. Strong and weak acids. Acids may be strong or weak. The acid which produces more hydrogen ions, H positive, and dissociate completely on dissolving in water are called strong acids. Example, sulfuric acid, hydrochloric acid. Acids which produce much less hydrogen ions, H positive, and do not dissociate completely on dissolving in water are called weak acids. Example, acetic acid, lactic acid. Organic and inorganic acids. Organic acids contain carbon as a constituent and are found in living things, plant and animal material. Example, citric acid, formic acid, and acetic acid. These acids are naturally occurring. They are weak acids and that is why we use them as food supplements. Inorganic acids, mineral acids, on the other hand, are prepared from minerals present in the Earth's crust. Inorganic acids are prepared artificially in the industries. Example, sulfuric acid, nitric acid. You use some of these acids in your chemistry lab. They are strong acids and so need to be handled with care. They should not be tasted or even touched with hands as they are extremely corrosive.
Acids, on dissolving in water, dissociate into cations and anions. The solutions conduct electricity and hence behave as electrolytes.
Metals react with acids to varying degree. So glass bottles are used to store acids. Ask your grandmother why she does not store pickles, tomato ketchups, and fruit juices in metal containers. Acid rain. The large accumulation of pollutants like sulfur dioxide, carbon dioxide, nitrogen dioxide in the atmosphere dissolve in the moisture of the cloud, forming acids such as sulfuric and sulfurous acid, nitric and nitrous acid, and carbonic acid. The first showers of rain in a highly polluted area thus has high acid concentration which harms plants, animals and buildings. This is known as acid rain. Bases. Taste a pinch of baking soda. It has bitter taste. Make a solution of baking soda in water. Put a teaspoon of this solution on your hand and rub it with your fingers. It has a soapy feel. Substances which are bitter to taste and feel soapy on touch are called bases. Materials containing a base are called basic substances. Bases are substances that produce hydroxyl ion OH negative when dissolved in water. Greater the number of OH negative ions produced, the stronger is the base. Bases that are soluble in water are called alkalis. Example, sodium hydroxide, potassium hydroxide. Many bases do not dissolve in water. Example, aluminium hydroxide, magnesium hydroxide. All hydroxide compounds are bases, but only water-soluble bases are alkalis. So, we can say that all alkalis are bases, but all bases are not alkalis. Indicators. We cannot have a system of testing all kinds of acids and bases by our taste and touch for the simple reason that many of them are so strong that they will cause severe acid or alkali burns. Special substances are used to indicate if a substance is an acid or a base. We call these chemical substances as indicators. Litmus, turmeric, and China rose are some of the indicators obtained from nature. These indicators show by color change whether a given substance is an acid or a base or neither. So we can say that indicators are substances which show a change in their color when brought in contact with acids and alkalis. The change in color is intense. A very small quantity of indicator is needed to see the change. The indicators do not affect the nature of solution to be tested, that is, they do not react with any solution.
The commonly used indicators in the laboratory are litmus, phenolphthalein, and methyl orange. Differences between acids and bases. Acids, bases. 1. Acids have a sour taste. Bases are bitter in taste and slippery to touch. 2. All acids are soluble in water and their solutions conduct electricity. Not all bases are soluble in water. Soluble bases are called alkalis and these can conduct electricity. 3. They produce hydrogen ions H positive when dissolved in water. Bases give hydroxyl ion OH negative in their aqueous solutions. 4. The number of replaceable hydrogen atoms in an acid is called its basicity. Example, HCl is monobasic, H2SO4 is dibasic, H3PO4 is tribasic. The number of replaceable hydroxyl ions in a base is called its acidity. Example, NaOH is monoacidic, MgOH2 is diacidic, FeOH3 is triacidic. 5. Acid reacts with base to produce salt and water. Base solution reacts with acid to produce salt and water.
pH. The strength of an acid or an alkali is also represented by what is known as pH scale. The pH scale varies from 1 to 14. If the pH of the solution is between 7 to 14, it is a basic solution. A solution having pH value 7 is termed as neutral. Example, water. Acidic substances have pH value less than 7. Universal indicator. A universal indicator is a combination of dyes that shows a change of color over a range of pH. These are also available as strips of paper. The change in color can be matched with a standard color chart to find the pH. Neutralization. When acids are mixed with base solutions, they tend to destroy each other's distinctive properties, that is, an acid destroys the properties of a base and a base destroys the property of an acid. The resulting solution is neither acidic nor basic. It is termed as neutral and the reaction is called neutralization reaction. Applications of acid-base neutralization. Soil testing. In order to neutralize the acidic nature of soil caused by excessive use of fertilizers or by acid rains, the soil is treated with a base such as slagged lime, CaOH2. If the soil turns alkaline, organic matter is added to the soil which releases acids by the action of microbes that neutralize the alkalinity of the soil. Acidity in stomach. When you have regurgitation, you get a sharp taste of strong hydrochloric acid produced in the stomach. Sometimes too much acids in the stomach causes sharp pain and the doctor advises antacid to neutralize the extra acids. Drinking plain water gives some relief as the stomach acid is diluted. Antacid. These are available as tablets or gels containing magnesium hydroxide or aluminium hydroxide to neutralize the gastric acid of the stomach.
Antidotes for sting. The sting of a bee or an ant is painful as it contains formic acid. It can be soothed by using a paste of baking soda or calamine solution which contains an alkali. On the other hand, the sting of a wasp contains an alkali which can be neutralized by vinegar.
Toothpaste are alkaline. Our tooth decay due to acid produced by fermentation of food particles in our mouth. By using toothpaste, which is alkali in nature, acids are neutralized to keep our teeth decay free. Acid burns. Burns caused by acids are comparatively more serious than burns caused by alkalis. In both the cases, the affected part of the body should be washed with plenty of cold water. In case of acid burn, a dilute solution of baking soda may be sprinkled on the affected body part. Treatment of sewage waste. Industrial waste products contain dangerous chemicals like acids. If they reach water bodies, they may affect aquatic life. A large number of fish, cattle, and other organisms may be killed. Therefore, the sewage waste from factories are treated with base to neutralize it and make it harmless. Salts. We know that during a neutralization reaction, acids and bases react to form salt and water. The most common salt known to us is sodium chloride or common salt. Every salt has a metal part and a non-metal part. For example, in the salt, sodium chloride, sodium is the metal part and chloride is the non-metal part. The name of the salt is derived from the name of the metal contributed by the base. The non-metal part of the salt comes from the acid. In the above example of sodium chloride, sodium is derived from the base sodium hydroxide and chloride is derived from the acid hydrochloric acid. Hydrated salts. The crystals of some salts have a mixed number of water molecules specific to a particular salt, loosely associated with them. Such water molecules are known as water of crystallization. These water molecules give shape and color to the crystals in some salts. Such salts are called hydrated salts. On heating, hydrated salts lose their shape and color and change into a powdery substance. Such salts are called anhydrous. They regain their color when water is added to them. Some other salt types are A. Double salts, B. Mixed salts, C. Complex salts, etc. Uses of acids, bases and salts. Uses of acids. 1. Sulfuric acid and nitric acid are used in the manufacture of fertilizers, paints, explosive and other chemicals. 2. Hydrochloric acid is used in leather industry and printing. 3. Acetic acid and benzoic acid are used in food preservation. 4. Citric acid is a source of vitamin C in soft drinks. Uses of bases. 1. Calcium hydroxide is used in making bleaching powder, softening of hard water and neutralizing acid soils. 2. Aluminium hydroxide is used as foaming agent in fire extinguishers. 3. Magnesium hydroxide is used to manufacture antacids, a frequently used medicine. 4. Sodium hydroxide is used in the manufacture of soaps.
Uses of salts. Different salts are used in our day-to-day life. Their use depends upon its unique property. One such property is hygroscopy. It is the property of a salt to absorb moisture from the environment without getting dissolved in it. With silica gel, quicklime. Have you noticed small cloth bags as you open sealed packs of electronic items? These bags contain desiccating agents that keep the gadgets dry.